here in this lesson, we are going to learn about midpoint and the distance formula. So why do we need to know this? To find missing lengths. But first, we have to talk about more vocab. So in the last video, we learned about segment congruence, which means that two line segments have the same length. So if I'm looking at this, get my pointer on here. I'm looking at this line segment AB, and I have this point that causes both of these segments, AM and MB, to be equal. I call this point M the midpoint. The midpoint is going to be a point that divides my segment into two equal or congruent segments. So I can say here, remember I would mark this if these are congruent like this that we learned last time. And I can say that AM is congruent to MB, but the lengths are equal, just so that we are reinforcing that idea. Segments are congruent, but distances or lengths are equal. So another vocabulary word that we have to talk about is a segment bisector. So a segment bisector basically is anything that will cut your segment in half. So the reason I say anything is because it literally could be, you could have a ray, a point, a line, a segment, or a plane. All of those things could cut your segment in half. So the key thing that I want you to remember is when you see the word bisector, bisector means cut in half, okay? Both of the sides are going to be, the pieces that you chop are going to be equal. That's all you need to remember. Bisector, cut in half. Okay, so here is, this one's a little bit of a harder example, but I wanted to kind of give you a more like algebraic example to show you how this works. So this one says that M is the midpoint in my segment, and I want to find PM. So if M is the midpoint, first thing I'm going to do is I'm going to mark it. I'm going to mark these segments are congruent with my little tick marks. And then since it's the midpoint, I know that they're going to, my distances are going to be equal. So I know that PM is going to equal MW. Now, okay, well this distance right here, PM, well that's this much, and MW is this much. So I can actually write myself an equation. I can say that 4x minus 1 is equal to 3x plus 3. So in order for me to find PM, I'm looking for this length right here. That's PM. But I have to first find my x value. So to find x, I'm going to draw a line down the middle like this, and I'm going to get x on the side by itself. So I like to get all my x's on the left-hand side. So I'm going to take these three x's and I'm going to move them to get my x's on the left. So that goes away. 4x minus 3x is x. So I get x minus 1 equals 3. Now I have to move that negative 1 to the right side. The opposite of negative 1 is positive 1. I'm going to add 1 to both sides. So I get x is equal to 4. Okay, but that's not my final answer because they want me to find PM. So to find PM, I have to take this 4 and then plug it in where I have an x. So PM is represented by 4x minus 1. But remember, x is equal to 4. So right here in this space, because x is equal to 4, right here, I'm putting a 4. 4 times 4 is 16. 16 minus 1 is 15. So PM equals 15. Okay, next thing that we're going to talk about is the midpoint formula. So you might say, well, why do I need a midpoint formula? It's really easy, it just cuts my segment in half. Well, what if you have a line that you can't just count to figure out how long it is, or you can't just subtract? You can only just subtract, like what we learned last time, if it's just a plain horizontal line or a plain vertical line. Otherwise, you don't know the distance of it, and you're not going to be able to just count to find the middle. So we have a midpoint formula. So what this says is I have these m's here because m stands for my midpoint value for my x, and my midpoint value for my y, because I'm now dealing with something in the coordinate plane. So what I'm going to do is I have each value, we're going to call this one 0.1, and we're going to call this one 0.2. So my midpoint, xm, ym, just going to kind of fill out my skeleton here. Okay, plus. So here, this is saying in my 0.1, what's my x value? This one says, in my 0.2, what's my x value? This one says, in my 0.1, what's my y value? And this one says, in my 0.2, what's my x value? So I fill in all these values. So I have -3, 1, 1, -1, divided by 2, divided by 2. Okay, now I mathematically figure this out. This and this are separate, so I'm figuring out here's one and here's the other. So on the left, -3 plus 1 is -2. On the right, 1 plus -1 is 0. Now I simplify. -2 divided by 2 is -1. 0 divided by 2 is 0. So my midpoint, is my final answer, is -1, 0. So let's just check. If I go to -1, 0, and I was to draw in my line, does that look like it's in the middle? Yeah, it does, because it's the same. Look at the distance is the same. I go down 1 over 2, down 1 over 2. It's the same. It's in the middle. That's a good way to check visually. Okay, the last thing that we're going to talk about in this lesson is the distance formula. In this last example where we talked about midpoint, I said, well, what if you can't just figure out the length of your line, right? Like if I have a vertical line, I can just count how long it is based on my grid paper, right? If I have a horizontal line, I can just count how long it is based on my grid paper. Well, what happens if your line's diagonal? Haha, can't just count. So that's what the distance formula is for. Okay, we read the formula in the same way. The formula is just a little bit different. Okay, so I wrote this out for you. The distance formula is equal to the square root of everything underneath. So I take my x values, I subtract them and square it. I take my y values, subtract them and then square it. Okay, so we're going to read this the same way. For purposes of this problem, we're going to call this one 0.1 and this one 0.2. The reason I like to label it is so that I'm consistent with the way that I do my subtraction. Because if I subtract 1 minus 2 and 2 minus 1, then I'm going to get a wrong answer. Okay, so in my 0.2, what's my x value? In my 0.2, my x value is here. In my 0.1, what's my x value? Here. In my 0.2, what's my y value? Here. In my 0.1, what's my y value? Here. So I'm going to fill all these in. So I have 1, -2, 2, -2. Now remember, this is a subtraction. Okay. Now again, I'm finding my distance or my length, so I just have my AB written with no line or segment above the top. And when I'm doing subtraction, remember subtraction is the same as add the opposite. Add the opposite. So I end up with 1 plus 2, which is 3, and 2 plus 2, which is 4. I square first, so the square root of 3 squared is 9, 4 squared is 16. Add these together, 9 plus 16 is 25, and the square root of 25 is 5. Now all your answers might not be so nice and neat, so feel free to use a calculator if you have to, If you need to use the Desmos calculator, www.desmos.com/scientific. Okay, if you need help, you can literally type in the whole expression the way that we wrote it out initially, and it'll figure it out for you. It's a pretty handy calculator, and you can download an app, by the way. Looks like this one. You can't see it. It's this one that has the cube root of 27 that says scientific underneath. Okay, that's the app you want to use. So anyway, I can say that AB, my distance, is equal to 5. Let me know if you have any questions about midpoint or distance. Good luck.